Let's take a look at a problem where we're looking at expressing quantified statements in equivalent ways and then finding the negation of quantified statements. This is an area where many students struggle with trying to understand the concepts. Keep in mind that you can also watch checkpoint videos or visit your multimedia library for more resources. First of all, our statement says, not all people are temperamental. So how are we going to go about negating that? Not all people are temperamental. Comparably, we could say some people are temperamental, or at least one person is temperamental. So how could we write it? Let's see. Let's take a look. All right, so we got that one. But now we want to negate it. We said some people are not temperamental. We want to negate it. Well, it's not negating it to say that some are temperamental, because that's really not arguing the point. If you say that some people have red cars, the understanding is that some people do not have red cars. If you say that some people get angry easily, it's kind of understood that other people do not get angry easily. So we're looking to negate the statement, some are not. We're not going to choose some are not, because that's saying the exact same thing. We're not going to choose that some are. What we're going to choose is that all are temperamental. It's not negating it to say that all people are not, because that would still include that some that are not. I know this sounds confusing, but if you think of it this way, let's talk about cars for a minute. Some people do not drive red cars. If I said all people do not drive red cars, I'm still including that first set of people. So I really was not totally disagreeing with that first statement. I need to find the complete and total negation, which would be to say that all people drive red cars. Here's a statement. No planets are larger than Earth. This statement is false. So we want to find the one that would say not P. No planets are larger than Earth. So if we say that none are, the negation is that some are. We're going to continue the problem. What can we conclude about the resulting verbal statement? Now keep in mind the original statement was false. So that should indicate to us that not P, or the negation of that statement, should be true. Remember, we have a law of excluded middle, meaning that a negation and the original statement must be opposites of each other, true and false. There is no middle road. Here are two sets. One is college students, the other is biology majors. If you look at these two sets, you will see that the circles do not overlap. If this is the diagram indicating the relationship between the two sets, we can see that no biology majors are college students and no college students are biology majors. These circles do not overlap. No college students are biology majors. Is the statement in that first part true or false? Good question. Let's think about this for a minute. Is this statement true or false? No college students are biology majors. Oh, that's right. I have to think about this. First, I have to consider whether that statement is true or false, and then I need to consider its negation. I should have read the directions. Determine if the statement is true or false. If it's false, write its negation. Well, in real life, that is truly false. We're saying in part A that no college students are biology majors. So in part B, if we're saying none are, then the negation would be that some are. So we've indicated the truth value of the statement by going back and reading the directions and then determining the negation. So this is a valid statement. Some college students are biology majors. Again, similar side of example, college students and business majors. And I'll let you try that one on your own. Good luck.